Hi, everybody. Welcome to today's office hour, Accelerating Hive with Alluxio on S3. My name is Amelia, and I will be your moderator. Before I introduce you to our speaker, I have a few housekeeping items. All participants are automatically on mute throughout the session. We will be using Slack to communicate, so please take a moment to join us on the community Slack channel, which is copied into the chat box. It's alluxio.io/Slack. However, if you are having trouble joining Slack, you're welcome to message me your questions instead, and I will share it with the group. Today's session will be split into a quick presentation followed by a really cool demo. We will have a Q&A session throughout the presentation, but if you have a question, you can also ping me anytime, and we will definitely address it by the end of the presentation. To ask a question, join the community Slack channel posted into the chat box. Lastly, today's session is being recorded and will be available for on-demand playback. We will be sending out the link to the presentation as well in the following days. That's it on the housekeeping side, so let's meet our speaker. I'm very pleased to welcome Bin Fan. Bin Fan is the founding engineer of Alluxio and the PMC member of Alluxio Open Source Project. Prior to Alluxio, he worked for Google, where he won the Technical Infrastructure Award. Bin received his PhD in computer science from CMU, working on distributed systems. Without further ado, I'll pass it on to Bin.
Thanks, Amelia. Good morning, everyone. I'm glad to be here to host the office hour and talk about accelerating Hive with Alluxio on S3. So this is today's topic. I want to briefly introduce the agenda today. I want to talk about why you want to run applications on S3 with Alluxio, and then followed by a little bit introduction into Alluxio itself. And then I will leave some time for Q&A and finish my demo with you. And by the way, as mentioned by Amelia, we're using Slack channel as the Q&A. And if you have any question during the presentation, feel free to raise your question there. And we will be happy to pause and answer the question. So basically, I like the whole presentation to be more interactive. And first of all, why more and more people running their applications, especially data-driven analytics on AWS S3? There are a couple of reasons from the users we see. And one of the reasons is they have the relatively cheap storage compared to traditional distributed storage like HDFS. And also, S3 is maintained by AWS, and it provides high availability across different regions and different zones. S3 is also fully managed. Basically, you can use this as a service. You don't have to put any effort to make sure it's up. And S3 is highly scalable, and a lot of large-scale users are dumping billions of objects or millions of objects into S3, and they can just use S3 as a very reliable and scalable storage. However, even S3 has so many different advantages. People are still seeing S3 as different as the traditional file system services. There are a few reasons why you can have I/O challenges to migrate your data-intensive analytics directly by running these analytics simply on S3-based stack. And the reasons include you may have slow object listing. If you have an analytics planning is required to list all objects or files in a directory on S3. And this is actually a very common operation for a lot of SQL engines like Spark or Hive. So they have to monitor all the different objects inside the table partitions, so they can just make corresponding query plan. And also, due to the implementation details, or object store in general has a very different semantics as a file system. So one other reason is the rename becomes very expensive to support in object store. And the reason is because rename on the file system land is typically it's a pure metadata operation by changing the name for inodes inside a tree and without touching anything. But rename becomes both metadata operation and the data operation on object stores like S3. And what you do is it's not only change the name, but also copy the old objects into the new name and delete the old objects. That's why if you have tons of different objects, and especially the objects are big, and the rename operation on the directory can take a long time. And this is actually creating a lot of issues for analytics applications like Spark, MapReduce, or Hive. One of the reasons is these applications typically are designed to work with a distributed file system, which can simply assume rename is a relatively cheap operation on a directory level. And they often use this as atomic operation to commit the final result. So on S3, this is no longer true and can create a lot of performance issues. And also the throughput throttling is commonly observed. If you have a very data-intensive workload running and dramatically for example, in the final phase to output results, you may see the throughput to S3 read or write data to S3 can be throttled. And this is because on S3 side, they have some mechanism to protect how much rate they can handle. And so this throughput throttling is very rare to see in the deeply coupled stack like Hadoop, because in that situation, the stack, the data and compute are deeply coupled. So typically you don't have this throughput throttling, and you don't have to handle this throughput throttling on the application level. Event consistency is another major difference in S3 versus in a distributed file system. S3 provides a little bit different semantics into what you can see and what you can write, what you can get after putting some objects into this service. So if you're interested, you can learn more about this. Go to AWS official documentation. And interestingly, according to a lot of our users, they also report the variable performance in S3 by reading data from S3 in different time of the day or in different days. And it's because the data is no longer co-located with compute. So there's no data locality, of course, on the computation on Hive or Spark. And also there's no user managed cache. And all you can do is to use use S3 as a data lake. And there's no middle layer in between, a transparent layer in between. So there's a recent guest blog written by Yunling Cai in Alluxio website blog. And you can take a look, and it shows her experience when using Alluxio with AWS to address these challenges. So if you're new to Alluxio, this is what we're doing. It's an open source data orchestration layer, and it's in between computation layer and storage layer. So by being the open source data orchestration, it has different meanings. And what we are trying to emphasize here is it has the flexibility for applications. It builds a data abstraction on top of object stores and file systems. So different applications like Presto, Spark, or Hive, or TensorFlow can talk to this data abstraction without worrying where the data is stored and how it is stored and and in which format it is stored. So Alluxio as a data orchestration layer provides different APIs like Java API, HDFS API, or even S3 or POSIX APIs to these applications to expose the same data abstraction. And on the southbound, we provide different built-in drivers. You can use Alluxio to inject or to dump data to persistent data storage or services like S3 or Azure or HDFS. And you can also mount, or in our terminology, mount, put different data sources into the same file system abstraction tree. And from the user's perspective, they just view this as the same data abstraction without even noticing they are from different data sources. So I will go to the details in later slides. So the benefits put Alluxio in a typical AWS stack include at least first, provide a better consistent performance, query performance. You can think we're adding Alluxio as a data caching layer on top of S3, so you can cache the hot data or the metadata in this layer. and provide you the familiar file system semantics and get a very relatively cheap listing and cheap rename. And in this way, users can be very agnostic about where data is from and whether data is in Alluxio or not. So if the data is already cached into Alluxio, that's fine. You can just get this with a shortcut. If the data is not in Alluxio, that's still fine. And this caching layer will behave on behalf of the users to cache this data into this tier. We have a distributed storage engine with Alluxio, so we can just put the data in there, and you can control replication, you can control data policy, the TTL, and to make the data in a better format, in a better layout for your application. And besides, we also have the data provided more data locality for applications, traditional, conventional analytics applications like Spark or Hive, which typically assume the data, which typically can leverage the data locality to get a much better performance. So in their scheduler, the typical way is if they think I'm talking to a distributed file system, then I will check where is my data. If the data is on a node which is also running my Spark, can also run my Spark task or Hive task, then I will try to schedule the task to that node. So you can imagine this is a perfect design for a Hadoop-based stack. But if its data is all in S3, then all data will be remote. Versus in here, if you put Alluxio as a caching layer on top of S3, but deployed close or even co-located with nodes running Spark or Hive, then Alluxio can provide a similar information to Spark and Hive on the HDFS interface to improve data locality. And also, as mentioned, like Alluxio, it can be used as a single namespace abstraction, and you can mount different data sources into the single data namespace. So files and objects can be from different storage like GCS, Azure, or HDFS. And objects can be also in different S3 buckets, as I will show you later in my demo. A little bit of history about Alluxio as an open source project. It originated as a research project called Taikiang from UC Berkeley AMP by PhD student Haoyuan Li, who is the CTO for Alluxio company. And this open source project starts as a sister project for Apache Spark. And in the early days, Spark is using Alluxio as the in-memory off-heap distributed storage, block storage. So later on, this Alluxio is open source, and we developed this into a more general purpose system, not just working with the Spark, but also working other systems like MapReduce, Hive, Presto, or TensorFlow. So we have the company also called Alluxio to commercialize Alluxio, open source Alluxio projects, and backed by Andres and Harold. So this is a very fast-growing open source community. We have more than 1,000 open source contributors on GitHub, more than 4,000 GitHub stars. The project itself is it's just like the other open source, a lot of open source projects in a similar space. It's under the most permissive Apache 2.0 license. We have a community Slack channel. As I mentioned, we will do Q&A in this Slack community channel, and you are welcome to join this Slack community channel, not just for Q&A, or in general, if you see any issues, have any questions about Alluxio, I'm always there, and a lot of other project maintainers are also very active on the Slack. And you're also welcome to contribute to our open source. Let me go to a little bit details to the next level, like what you can do with Alluxio, why it provides benefits in performance, in maintenance, or ease of use. For example, you can deploy Alluxio co-located with applications like Spark or Presto or Hive, and in this case, Alluxio with its own distributed storage engine can handle or can manage the memory resource or SSD resource or hard disk resource and treat them as a black box for a resource, storage resource for applications. And once you are accessing data from S3 or Google Cloud or some different storage, and Alluxio can help you to track data access pattern and keep the hottest data in the RAM tier. Given you have multiple tiers, keep the hottest data in the RAM tier. the relatively warm data in the SSD tier and the cold data in hard disk tier, and eject some other data, but leave them persisted in the original storage. So from the user's perspective, I'm just reading the data, but based on the temperature of the data, Alluxio can place them into different tiers to help the performance. So this is intelligent multi-tiering caching to help the local performance. And then the other benefits, as mentioned, is Spark or Hive or Presto. Their scheduler typically leverage the data locality information. So if you're running Alluxio co-located with these applications, Spark scheduler can be smart enough to assign tasks to the workers running Alluxio there also, and to get the local data without needing to read from remote or cross network. And we also provide different APIs, as I shown here. You can use for Spark or Presto, you can pretty much just use this as a very simple HDFS replacement by changing the URL from HDFS / into Alluxio. And also, if you mount Alluxio service as a local folder into your local file system through the the Fuse integration, and you can use your familiar Linux tools like bash commands or even TensorFlow to interact with the data here. We also provide a native Java API, so if you want to fully utilize all the functions provided by Alluxio, and this is the API you should use. And yeah, this is the data abstraction, and we are providing different connectors, so you can mount a S3 bucket into the data namespace, Alluxio namespace as a logical file system, and you can mount different storage or mount different buckets into the same namespace from user's perspective. This is a very simple, and they only need to handle one address, one unified address, and that's it. So for a lot of data admins, this can greatly simplify their life. There are two different typical use cases for Alluxio. One is for performance. You can put Alluxio as a caching layer for cloud analytics. For example, in the demo I'm showing today, you're running Hive on top of Alluxio backed by S3. And in a lot of other cases, we also see for bigger or more established enterprises, they are looking for a solution for hybrid cloud. What I mean by hybrid cloud is really leveraging the computation resource in the clouds provided by Amazon or Google or Amazon, but being able to talk to the data in their own data warehouse. So you may still run their HDFS as a data warehouse. For some reason, you don't want to migrate the data fully to public clouds, but you want to leverage the computation resource. So Alluxio can handle this, what we call the zero copy burst. By connecting Alluxio with the on-premise data warehouse, you can migrate data to public cloud on demand, and you don't have to, by setting data policies, you don't need to do this ETL explicitly, and you don't need to manage the data explicitly. Alluxio can handle this to you, and you can help. You can benefit from installing or enforcing the data policies like TTL or replications to simplify the data installation process. So we see two typical deployment approaches. One is to put Alluxio co-located with computation. In the case on the left-hand side, you may run the same instance for Spark or like a MapReduce with Alluxio and connect this with AWS. So co-located workers with Spark for optimal I/O performance. And the other way we see also is if you're having more ephemeral data frameworks, like you just launch Spark for different queries or run Presto for different queries, launch different Presto clusters for different queries, but you want to benefit from previous queries, the data access pattern in previous queries, you may run Alluxio as a standalone service in the cloud and connect Spark and Presto to this instance. So the benefits is even the Spark cluster goes down or the Presto you tear down, you can still have the data cached into Alluxio space. But the downside is you may lose data locality to some degree because you now fetching data across network, although it can be close in the same zone or same availability zone. Okay, so particularly today, I want to demonstrate a EMR running EMR Hive with the Alluxio. And to have the EMR with Alluxio, we provide a Bootstrap script. So you can simply run your EMR cluster through the normal way, create an EMR cluster, but by hooking Alluxio Bootstrap script there and to set up an Alluxio cluster. And what you need is the S3 buckets and a key pair to access EC2 and have AWS command line available on your local desktop machine. And then you can just use the Bootstrap script to bring up a quick cluster to test drive Alluxio. So I will show this in a few minutes. And want to give a little bit more details about what we do in the Bootstrap. So essentially, the Bootstrap is very simple. We want to inform different components in the EMR to be aware of Alluxio, be aware of how Alluxio client is installed, like where you can get this Alluxio client, and that's it. But if you want to have more advanced configuration, setting Alluxio configurations, that's also the place you can set. So I will show the demo, and you can see where I set these different things. So yeah, so we will, and so this is basically what we do for the EMR script. And I will leave this time to Amelia to talk about what data orchestration summit we're hosting, and while I'm setting up the demo.
Hi, everybody. While Ben's setting up the demo, I'm just super excited to share with you guys that we are organizing and hosting the first Data Orchestration Summit on November 7th at the Computer History Museum in Mountain View. This event, you can think about it as all things data engineering. We will be seeing speakers from Netflix, Walmart, Apple, Google. As you can see, our website for the list of current speakers. To present on some of the top-of-mind challenges and solutions to today's biggest data engineering problems when it comes to building data and AI platforms. It's a really cool event. It's a one-day, single-track, very sort of curated content and very targeted audience. You're going to have a great time. Also, some perks are, there's going to be lunch and happy hour. Aside from the great content, you'll also get swag, a free voucher to go back to the Computer History Museum at a time that you choose, as well as a chance to win a raffle for an iPad Pro, the latest iPad Pro. So it's a really great event. I'm going to post the conference site link into the chat box, and I'll also share a code with you guys. If you guys register with this code, you'll get a discounted early bird ticket. And let me know in the chat or questions if you have any questions about this conference. But I'm super excited and hope to see some of you guys there.
Thanks, Amelia. So yeah, let me go to the demo part and tell you what I'm doing here. So actually, let me just run the demo directly. Yeah. So can you see this one? Can you see it? So what I'm doing here is to first I will start a cluster, and this cluster is launched using a standard EMR create commands, and let's call this. So this is a very simple command. Let me explain what I'm doing here. So I called this command to create a cluster with 3 nodes. So one of them will be Alluxio master or the EMR master, and the other 2 will be worker or core nodes. Instance type, I'm using M4 X large, and I right now I'm only bringing in the application of Hive from EMR stack, and I gave this cluster name called test class 3. And I have been using this is a public bucket serving the EMR Bootstrap script with some extra configuration. So the configuration I actually downloaded in here with some detailed, like on the Hive side, setting this using MapReduce of the execution engine. On the Hadoop core side, set some Alluxio configurations. And actually to run Hive on Alluxio, to run EMR Hive with Alluxio, setting this is very important by going to the end. By setting the Alluxio client into this property, so the MapReduce will be able to find Alluxio client jar. Otherwise, it will complain, doesn't know how to explain how to find file system scheme Alluxio. Yeah. Okay, so this will take a few minutes. Let me just also bring up the EMR. Yeah, so this is the EMR console, and it's starting and will take a few minutes. Meanwhile, I would like to use this moment to answer any question if you have, and can go to Slack or probably directly message Amelia.
All right, we have a question here. Can I use Hive with Alluxio for different S3 buckets?
Yes, actually, this is part of my demo. I will show you how I mount Alluxio with a root directory with one bucket, but use the mount command to bring in another bucket to the Alluxio namespace. So the abstraction looks like these are the same single file system namespace, but actually the files are backed by two different buckets here.
And the next question we have here is, can Alluxio be used in different public clouds like Azure or GCP?
Yeah, so although the demo I'm showing today is about running Alluxio in AWS, but actually you can also do the same thing on GCP or on Azure. So I have been testing Alluxio on Azure a long time ago. So yeah, so it's agnostic to which cloud you are using.
We have another question. If I'm using AWS Glue Catalog for table metadata, can I create Presto table using Alluxio namespace now? A month ago, I remember I can only create table in Hive, but not Presto.
Yeah, so I remembered I remember this. I think previously the reason you cannot create Alluxio tables from from Hive on Alluxio is there are some check on the Alluxio client side, and I believe in 2.01 we fixed that, so you should be able to create tables on Presto, but I'm not fully sure about that, but I can double check. But this is a great question. If possible, you can also leave this as a GitHub issue, and we will go back to get this answered with like engineers working on this.
Okay. Feel free to keep your questions coming, guys.
Yeah, the cluster is starting. It takes a few more minutes. So one interesting thing I really like to use EMR is it's very easy to set up, and it's very easy to tear down too. And everything is pre-configured. You just need to run one single command to bring up the cluster, and you can play with it. And but like right now, the EMR stack has no Alluxio component inside. So that's why I need to run this command here by specifying the Alluxio start bootstrap script. So basically, this is the Alluxio bootstrap script on EMR. Yeah. So it's I mean, it's to me it's convenient enough to run something like Alluxio on the EMR stack right now on AWS. And we're working with Dataproc on Google Cloud and on the same direction. Okay, so the cluster is ready. let's go and explore. So first, this is how I go to this cluster. So I'm logging to the EMR cluster with this is on the master node. So Alluxio, according to the Bootstrap script, is installed in this directory. It's under opt Alluxio. So what you can do is to first check whether Alluxio is running. So usually the first thing I do is to run this command. This is talking to the Alluxio master and see how many workers it sees and how many is in safe mode or anything wrong, any capacity. Yeah, so from this command line, you can see Alluxio's master is running on a single master mode with web port 19999 with RPC port 19998, and it has already up for 3 minutes and already finished the bootstrapping, so it's no more in the safe mode. Without Zookeeper and 2 workers here, in total we have 10 gigabytes memory space and use 0 bytes. Okay, so next thing I want to check out is how is Alluxio mounted? How is this space backed? So by running the fsmount command, you can see the root directory is mounted to a S3 bucket called Alluxio Quick Start, and I'm curious to see what else in this bucket. So you can run this. Okay, so I have 4 different files with different size. So the size is shown here. So one interesting number is the 0%. That means I have metadata. Like I know there are 4 files, their size, who created this, the time, timestamp, but I have no real data into Alluxio space yet. That's why you can still see the used capacity is 0 bytes. So to bring the data here, one way to bring the data here is to cat. For example, I used a small file. Okay, so basically we see 1 tweet with the word kitten inside. Okay, now if you run this command again, you will see this file has 100% loaded into Alluxio space. And the reason is because we run this already. And if you do this again, and this will return you, well, the file is too small, but if you try a bigger file, you can definitely see the performance difference. And the reason is because we have the data backed by Alluxio, or like cached in Alluxio, but backed in S3. Okay, so the next thing I will do is to create bring a different buckets with some table data inside. What I'm to run here is to let me change the IP address here. Okay, so here I'm mounting a different bucket. So previously the root mount is Alluxio quick-start. Now this is a different bucket, Alluxio APC999, which is my personal account. So I can show you this is what I have in my bucket. I have the EMR, and there's only one directory, single directory here. And if you're curious what we can see from Alluxio inside, you can run this, and this will show you we have some input data called ML100K, which we will query later using Hive. So in here, let me remove the output directory because I will use this later. Okay, so now if you run this again, you have only one directory. Now let's run some Hive commands. first, let's drop the table if the table exists. And now create a table called u_users with the updated Alluxio master URL. So this is an external table, and we can see the table is actually backed by, let's check what else in the table. So you can simply query the table by select everything from the table. Yeah, so this is the content of the table. And next, I want to show you how I can write something into using Alluxio using Hive. So I will create a new table. So now I'm creating a new external table with a similar schema with the previous table and pointing to a directory called EMR/output, which is a directory I just removed. And now the next command I'm running here will trigger a MapReduce job to read the data from the previous table and to write to a new table. Yeah, so this will take for a few minutes, maybe. The overhead although the table is very small, but the overhead to start MapReduce and to clean up the state, to keep up the state is, okay, I think it's done. Now let's just select star from the new table. Yeah, it has a similar content as the previous table. So basically, and if we quit from Hive and check what else on the Alluxio space, so you can see we have 100% data loaded from original table, and now we also have the table here from output in the output directory, which is a duplicated replicated table, and these under EMR directory. This is under one S3 bucket, but on here on the root directory, this is on a different bucket, and we can also check from the S3 side. You can see the directory showing up here with the data showing up persisted here. Yeah, so this is for a very quick demo, but you can imagine if you have a lot more files and a lot more partitions, and this will help you to simplify the workflow by having Alluxio in the cache as a caching layer, not only speeding up the performance, but also easier management across different runs, and you can only persist the data in the last stage, in the last job. Okay, so that's so much for the demo today. If you're interested, I will share the slides later, and these slides contain the instructions I use to run the different commands here. Okay, so that's so much for the talk, the quick presentation. I'm willing to take more questions.
And you're welcome to ask questions via the GoToWebinar question box, as well as the chat box or Slack. And feel free to ask questions even if it's not directly related to the topic that's been presented. We'll be hanging around for a bit, so fire away. All right, it's a wrap, folks. Thank you for joining us, and we look forward to having you guys in our next month's office hour. Thanks, Ben.
Thanks.